So can everybody hear me okay? All right. So first off, thank you everybody for showing up today and attending this event today. We at Crunchy Data are really excited to be putting this on for you. It's great to see a lot of familiar faces in the crowd and great to see some new faces here. Hopefully that means everybody here is interested in learning more about PostGIS and what it is and how it can benefit you in your daily life. So first off, just a little bit about Crunchy Data and who we are, for those of you that may not be familiar with us. So we provide support for Postgres and PostGIS for large enterprises. That takes the form of actual enterprise distributions, certified enterprise distributions of Postgres and PostGIS. We have 24/7 support as well as technical training that we offer to large organizations. So we're the market leaders for data security in Postgres. We're experts in managing your data in the cloud using Postgres and PostGIS, and we are the leader in open source Postgres support. And while we are an open source support company, our roots are basically they came out of supporting the DoD and IC. So when we say we provide market-leading data security, our distributions support national security workloads on classified networks, right, as well as personal information, personal health information in large healthcare organizations, right? So that's the level of security that we're talking about when we talk about market-leading enterprise data security. If you're interested in learning more about who Crunchy Data is, the types of services that we offer, the type of support that we offer, happy to talk with you about that during the breaks. Pretty much anybody wearing one of these PostGIS shirts that you were handed today can help answer your questions on that as well. We've got a variety of Crunchy Data employees throughout the audience, as well as on our speaking agenda for today. So, as I said, thank you for attending. We've got a really great agenda. You can see the agenda here. The morning agenda is projected behind me here. It's also out in the gathering area. And so the way the day is structured, the morning is going to be kind of a higher level kind of scene setter. For those of you that aren't familiar with what PostGIS is, what it provides, it's kind of get you familiar with what it is. And then in the afternoon, we're going to go into a little bit more of technical topics, specific features, functions that PostGIS provides. And then we're going to wrap the day up with a live demo of an application that we built in-house in Crunchy Data, just to show an example of how you can actually bring to bear the power of PostGIS on your geospatial data sets. So with that, give me 1 second while I switch over to my presentation. And I am also your first speaker for the day, so that makes transitions easier. All right, thanks. Cool, thank you. All right, so first talk of the day, spatial data and data-driven architectures, right? So this is the scene setter for what follows for the rest of the day. So first off, a little bit about me personally and who's talking to you about this stuff. So I like to say I'm an engineer by education, geoevangelist by choice, right? So I've got a little over 16 years of experience doing what I call following the data, right? And I didn't anticipate my career would end up like this. Just so happened to be how it ended up. So I've got a little over 4 years of experience in the Air Force. I started out working on satellite ground stations, right? And so that consisted largely of engaging with the users of that satellite data, understanding what needed to be done at the satellite ground station to pre-process, get it ready for actual dissemination to users so they could actually use it, right? After that, I was a defense contractor for about 4 years, and I moved from satellite systems to airborne ISR, or in kind of common vernacular, drones, right? And the data that comes from drones, whether it's full motion video, high-resolution imagery, LiDAR, hyperspectral, you name it, I got to play with some really cool advanced technology in support of our warfighters and our national security. And again, the kind of the main theme for my time in that part of my career was really understanding what the user's needs were, how they needed the data delivered to them, what they were trying to do with the data, right? And really, what was their mission outcome that they were trying to achieve with that data. After that, I joined the National Geospatial Intelligence Agency right down the street, as Mark said, and got to work with some really smart analysts that used a lot of that data and added a lot of human value to it, right? They did the gray matter work of really dissecting the imagery, the data, and producing additional GeoInt data. And again, the common theme through my time there was really understanding what were the user requirements, what did the data need to tell them, how did they need to manage the data, and what did they really need to get out of the data. And now, obviously, my current employer is Crunchy Data, and the main focus of my role inside Crunchy is really making sure that the services and the technology that we provide is providing value to the organization, right? Because at the end of the day, if we're not helping achieve organizational objectives and user objectives, then it's just technology for technology's sake, right? I'm a technologist, I love technology, but if it's not delivering end value to the organization, to the user, then it's really not all that great, right? You can see I've been an engineer, I've been a program manager, been a product owner. I've worked with military intel customers, and I've been a general technology leader for most of my career. And so I guess that's my way of saying, let's start at the end, right? So let's start at the end of why are you all here, right? You want to understand what is the value that PostGIS can provide to you as an individual, as an organization, right? And so we're gonna talk a little bit about that. So I don't think this should come as any shock to anybody in this room, right? Companies and organizations everywhere are trying to grow, right? They're trying to generate more revenue, trying to deliver better mission results, save more lives, create more values for their end users, right? It's just kind of a common everyday theme that we are all experiencing, whether it's for our own individual benefit or for the organizations that we work for. And so a common theme that you'll see a lot in the world today is data analytics, right? Data pipelines, big data, data science, artificial intelligence, machine learning. There's a dozen buzzwords out there, right? And everybody is clamoring, trying to figure out how they wring more value out of the data to help achieve those end goals that I listed on the previous slide, right? And so they're hiring more data scientists. They're investing in their people for training. They're spending a lot of money on technology. But the common foundational element in every one of these areas is data, right? It all boils down to data. How do you manage data? How do you analyze the data? In my experience, right, a lot of what I've seen is there seems to be a notion that we just haven't found the right algorithm yet, right? That, it's just the next algorithm that is going to unlock the utopia of data science, and it's going to yield all of the hidden insights that our corporate data has held locked in it for the past decades, right? That we just haven't been able to find, and so we're constantly searching for the next algorithm, the next piece of software, the next evolution in computing, right? And really, what it boils down to is you need to know your data. You need to know what's in your data holdings, and honestly, your data needs to be pretty well organized, right? I know there's a lot of conversation about unstructured data, right? Data lakes and just mixing all this data together. But if you talk to any data scientists, data analysts, they'll tell you flat out, the first thing you need to do is understand your data and what your data is good for, and then probably you actually need to organize your data, and you actually need to structure your data, even if it's semi-structured data, right? And so that kind of leads me to my next point here, right? And so if you're going about building your data analytics and machine learning AI house, right? It's sort of like building a physical house, right? You want to kind of plan out what your foundation is. And it used to be that for databases, you need to take a lot of time. You really need to analyze all of the data that you thought you would need to house in the database, right? And you'd need to make sure that you've fully scoped out the amount of compute space that you would need. And you'd have to make sure you ordered enough servers and had them in your data warehouse, right? And then you would carefully layer your database into your infrastructure, and then you'd load your data in, and you'd meticulously curate it, and your database was this pristine thing that you didn't really want to touch once it was set up, right? Because it took so much time and effort to get it going that you you didn't want to have to re-accomplish any of that work, right? That's not something that was really appealing to you, right? And so you had your house built, ready to go, and that's where you wanted to live. And if you needed to add more data to it, well, okay, now you got to go all the way back, and you got to break new ground, and you got to order new servers and stuff like that, right? And so that's still sort of prevalent in the world today. But really what we're starting to see is more akin to a structure like this, right? Where your foundation isn't dug deep into the ground and isn't something that is rigidly inflexible. It's more like your databases are your individual concrete columns, right? And you understand, well, how many databases do I really need for what data sets, right? And you build out just the databases that you need to deliver the value you need, and then you build your foundation on, or your house on top of that. And if you need to add to it, well, you add a couple more databases, you extend your house out on top of it, right? So databases have become much more scalable and quite honestly, a lot easier to create and manage your data with, right? And that's thanks to advents of data management frameworks and container management orchestration frameworks like Kubernetes and platforms and things like that. But too often what you see in large organizations is they put the cart ahead of the horse, right? They're like, oh no, hey, we got our data scientists and they've got their next neural network lined up. They've got their machine learning algorithms. They got their natural language processing algorithms. And so we're just going to throw data at them, right? And what ends up happening is your AI and machine learning analytics house crumbles, right? And it's just a shell of what it could be, right? And people are trying to live in that house still, and they're sitting there going, well, it sort of works, but we're not getting the results that we thought we were going to get from the investment in this technology and the investment in our people, right? And like I said, that harkens back to they overlooked the foundational element of really understanding their data and making sure that their data was properly managed and they had a solid foundation for their data that could actually do a majority of the type of analytics that they wanted to do on their data to begin with, right? They overlooked what was basically right in their own backyard, and they didn't do some basic analysis of the data to begin with to understand really what was needed for their data, right? And so now this is where I'll go into a little bit of we'll say plugging of a particular solution, right? But again, this is all about being community and open source, right? So we're gonna talk specifically about open source solutions primarily for the rest of the talk here, right? So if you're focusing on the data, obviously you want to make sure your data and your database should be secure, right? Nobody wants to be the next front page news of a data breach, right? Now I know there's supposedly no such thing as bad publicity, but I tell you what, front page New York Times article, that's pretty expensive publicity, and that's not necessarily the best type of publicity that you want. And I'm sure we've all heard about personal information, identity breaches, identity theft, things like that. I'm sure some of us in this room have been enrolled in credit monitoring programs despite our own individual best efforts to keep our information safe, right? Because our data was handed to an organization that we entrusted with our personal information, and they didn't make sure that their databases and that our information in their databases were secure. So obviously, first and foremost, you want your database to be secure. Once you've accomplished that security piece, right, obviously you want to make sure your database is highly available. It doesn't do anybody any good that if you've got this really secure database that nobody can use, which, by the way, the most secure database is a database that nobody can use, right? So there's a balance to be struck between usability and security and making sure that it's highly available. Right, so you want to make sure that if your database undergoes a heavy user load, that it can hold up to it, right? That if a zone in your cloud provider goes down, you've got failover and you've got redundancy. And that also goes to your backup strategies as well, right? To make sure that the data that you're holding in your database is always going to be there no matter what, and you can quickly recover from a potentially catastrophic event. So once it's highly available, then you want to make sure it's also scalable, right? So you want to make sure that you can add clusters, you can remove clusters, all very seamlessly and without any impact or noticeable impact to the user, right? The end user experience, the mission value should not be impacted by you trying to make your database and backend scalable. And then finally, you want to make sure your database is a highly performant database, right? There's trade-offs in all of these things, and at the end of the day, it could be a highly available, it could be a scalable database, but if it takes you 10 minutes to run one query in your database, it's not a very high performance database, right? So it could be up all the time, and you can scale it based on the user load, right? But if the users have to wait 10 minutes to get the results back, they're not coming back to your database, right? And so once you've accomplished all that, we at Crunchy feel like your database should be Postgres. No big surprise, right? Postgres is an incredibly powerful database. It has caught up and surpassed many proprietary options in the marketplace right now, and it continues to evolve, right? It's got a very vibrant ecosystem of contributors to Postgres, of which Crunchy employs numerous core contributors to Postgres and PostGIS. And so we really think that you should be taking a look at Postgres as one of your viable options in your enterprise to hold your enterprise data sets. All right, so you've got your scalable database. It's robust, it's secure. All right, but that's great. It doesn't do you any good if you can't get the data out and deliver value to your users, right? So how do you do that? All right, well, the common cloud-native development practices have a design pattern of you have your data sets, you build APIs on top of that, and you build services on top of that, and that ends up delivering business and mission value, right? And notice I inverted the triangle here, right? Because the biggest part of your architecture should not be your database, right? Your database should only be as big as it needs to be to support the mission value. Then your APIs layer on top of that, and you build only the APIs that you need to be delivering the mission value that you need. And you combine those APIs to form different services, and that all magnifies and hopefully is delivering inordinate amount of business and mission value to you, right? So you should be always amplifying and magnifying the amount of value that you get in each level. So what does that look like in kind of a typical PowerPoint engineering data architecture? So hopefully this shouldn't come as any sort of surprise to most of you in this room. This is kind of your standard three-tier cloud-native type architecture, right? And what you'll see there is the foundational element is your data tier, right? And you can see in any good data-driven architecture, you want to make sure you have a clustered database, so you're accomplishing all that. You're accomplishing a secure database, you're accomplishing a scalable database. You've got a highly performant one that can respond to your user load, and it's a high-performance database, and you're building services on top of that, and you're building it on and attaching those to the appropriate databases, whether it's your production database or your read-only database, and so you're addressing those through architectural considerations as well as technology considerations. And you can see at the API level, if you're building APIs out in microservices, you can pull those APIs together in different combinations to create new business value at the user interface level, right? And so this is just kind of your standard stereotypical three-tiered cloud-native architecture, right? So assuming that you've got this in place, right, and you've got your clustered database in place, you've built out services on top of that, and you've got your business applications. So the next question is, are you actually taking advantage of all of the data in your enterprise, right? And so that gets us to kind of the core part of why we're all really here today, right? So this day and age, it should be no surprise that spatial data is everywhere, right? You can't really go anywhere without interacting with spatial data, generating spatial data, consuming spatial data, right? And so the big question for all of you in your organizations is, should you be using it, right? And that's not a foregone conclusion, right? It may not make sense for you to use it, but me being a geoevangelist, I'm going to say you should probably at least take a look at it, right? Because it can actually unlock a lot of value for your organization, and hopefully by the end of today you'll realize you can actually do it in a fairly straightforward way using open source components with Postgres and PostGIS at the center of it. So here's some kind of typical uses of geospatial data, right? So you've got utilities, right, mapping out cross-country lines, understanding where they need to travel, even local utility work, right? Your utility companies have, or they should have, some sort of infrastructure map that they understand where lines are buried, you know, and where telephone poles are run. Urban planning, right? So you see the two maps down there, and so, all right, so here's my crowd interaction moment. Does anybody know what the lower right image is of? Sir? Oh, I'm sorry. My lower right, your lower left. Lower left. You still got it right. You still got it right. And again, so spatial learning moment, understanding your projection is very important, right? His projection was different from my projection. So now, that picture right there, lower left from your perspective. Yep, the new NGA campus, which is just going to be going about a mile from here. And then I also heard someone else say the new soccer stadium, right? Yep. So the next image over is for the new MLS soccer stadium to be built here in St. Louis. And then, yes, an image of precision agriculture. So you are correct. And so, yeah, so just, those are kind of your standard, stereotypical, traditional uses of geospatial data, right? Urban planning, utility mapping, precision agriculture. But what we're seeing is we're almost an overwhelming amount of new producers and consumers of geospatial data, right? So obviously you've got the big satellite systems, but then you've also got microsats, right? With Planet Labs and all the number of microsat companies coming out of the woodwork and launching these small satellites into low Earth orbit that are providing just an enormous amount of spatial data to unlock new insights on what's going on the Earth, right? But even things like your wearables, right? Your smartwatches, those are consuming geospatial data and they're producing geospatial data, whether you realize it or not, right? And then obviously we've got consumer drones, you've got professional, higher-end professional drones consuming and producing geospatial data, self-driving cars, point-of-sale devices, right? Anytime you swipe a credit card, whether it's a physical point-of-sale device at the grocery store or you're using a Square credit card reader, those are consuming and producing geospatial data, right? And that's being spewed out all over the place. And even smart thermostats, right? Your device on the wall that you think doesn't move at all, why would it need to know anything about its location awareness? First thing it asks you to do is, what's your zip code, right? It wants to know where you are so it can start learning based on your temperature patterns and combining that with weather patterns, right? So all of these things are producing and consuming geospatial data, and this is just a small sampling, right? Everybody's got a geospatial device on them right now, I guarantee it, and a smartphone, right? Those are spewing geospatial data left and right, and it's just being put out there for people to consume and take advantage of, and there are a lot of people doing that. So what if you're an organization that doesn't use any of those, right? What if you're an organization that just has your standard sales data? Well, if you've got sales data, I can almost guarantee you've got some sort of address information, right? Whether it's a general city location, specific consumer address, and so just by simply plotting it on a map, it sheds new insights into your sales data, right? Or even fire data, right? For land management. It's great to see a chart like that, right? So you can see kind of the spikes in terms of the amount of damage happening over the years, but that doesn't really convey where that damage is happening until you put it on a map, right? Once you place it on a map, then you can see where most of that damage is being concentrated in the country. And so just by adding a little bit of spatial awareness, spatial information to your data sets, it reveals new insights and enables new ways of visualizing the data. But so those are also, again, kind of your traditional displays of spatial data, right? It's a map. It's a map of the United States, and it puts dots on a map. But more and more, you're starting to see some very advanced visualizations, right? And when you add the time component to spatial data, you can really start seeing some really cool insights into what's going on in a particular region, right? So what you're seeing here is two representations of basically what a daily commute looks like in New York City, right? So the one on the top right is just kind of, it's almost the heartbeat of a city, right? You can see how people come into the city during the day, where they come in, where they're located during the day, and then where they go to at the end of the day. And it's a little bit harder to see down on your lower left, but that's a visualization of Waze data, right? So if you open up Waze and you're actively using Waze to get from point A to point B, they're recording that information, right? Now they're probably anonymizing it and stripping off all your personal information, right? But it gives you a different insight of the level of activity going on in a city, and that can be very insightful when it comes to things like urban planning, right? Where are your major congestion points? Where do you have a lot of accidents, right? What time of day do accidents happen? Things like that. So adding spatial along with temporal can really start unlocking new insights into your data. All right, so that's all great, right? But I know at one point I was asking, how do I get from that really generic inverted triangle to the end product of those interactive visualizations, right? That's usually where you get hit with the, oh, well, it's simple. Here's our GIS suite. Just go ahead and download here, install here, right? And oh, by the way, here's your license fee, and for every user, you need to pay a new license fee and all that type of stuff, right? Well, I'll go back to our data-driven architecture, right? So we got our data-driven architecture here. We've got our clustered databases. We've got our APIs on top of that, right? And so if you go to your enterprise IT shop, you go, hey, I wanna be able to build those awesome visualizations. They're gonna go, sure, here's your GIS, right? No, that's not what you want, right? You don't want your GIS and all your spatial data completely separate from all your business data, all your mission data, right? You want to be able to integrate all of that so it's easier for you to manage, easier for you to maintain, and easier for your developers to get access to that data, right? So let's get that out of here. All right, so here's one keen insight that I've gleaned over my 16-year career that I'm going to share with you. And it's a very well-kept secret in the geospatial world. Spatial is not special, all right? Come on, say it with me. Spatial is not special. There we go. Yep. All right, one more time. It's kind of therapeutic, right? Spatial is not special, right? No, it's not, right? Everybody wants to think spatial is special, and don't get me wrong, there's some uniqueness, right? You do need to understand how to work with the data, but from an IT perspective, spatial data is not all that special, right? It's a different type of data, it's a different format, and you do need certain functions to work with it, but it's not special. It's magic. Yeah. So my magician elephant friend here is gonna utter the magic phrase that is gonna help all of you unlock the spatial goodness in your data-driven architecture. All right, you ready? Here it is. Create extension PostGIS. And voila. Your data-driven architecture is now a spatial data-driven architecture. And so that's really the power that PostGIS provides to you as an enterprise, right? It's an extension to the Postgres database that you're already using, that your DBAs already understand, right? And it unlocks a new range of functions and features for your developers, for your data analysts, for your data scientists, right? It fits in with existing known design patterns, industry standard design patterns for cloud native architecture. It doesn't create a separate spatial architecture. It just adds and unlocks the spatial value in your existing enterprise data architecture. And so now the next question we typically get is, well, that's great, but I don't want to spend a lot of time writing all these custom services myself. That's a lot of work for me, right? All those APIs, I don't want my developers, I don't want my analysts having to spend a lot of time writing those things. Well, if you stick around for the remainder of the day, you'll see, one, that actually isn't as hard as it sounds, right, in the demo that we're going to be showing at the end of the day. And two, there is a very mature and continually growing geospatial ecosystem of open source components, right? And this is a small sampling, as well as there's also a very, very rich ecosystem of proprietary options, right? And the great part about Postgres and PostGIS is it integrates with all of them, right? There's integrations and bindings with all of these capabilities, so you can mix and match however you want. You can use the best tool for the right situation inside your enterprise, and you manage it all out of the same data framework in Postgres and PostGIS, right? And so actually what you'll see a little bit later this afternoon as part of our demo is we do actually use Tegla in our demo to show how to serve out vector tiles from PostGIS and as well as some custom written APIs that our team wrote. And so my takeaway, my get off the stage slide here is really open source is a viable and valuable part of your enterprise, right? We really think that it's something that you should be taking a serious look at if you aren't already using. Open source has come a long ways, and as I mentioned, it's a fully mature ecosystem, and Postgres in particular has surpassed many of the proprietary options that are available to you in your enterprise. And it also comes with a lot of great extensions to unlock and enable you to take better advantage of spatial data in your enterprise. And so with that, my final question to you is, what new insights and value can spatial data unlock for your organization? And so with that, that concludes my talk. If there's any questions, I'm happy to take them. Seeing none, thank you very much. I appreciate it.